Welcome everyone, myself Lakshya, and I'm going to introduce you all to our Elastic Auto Fixer agent, which we have made with all love and affection to participate in Elasticsearch Agent Builder Hackathon. To provide you in context, Elasticsearch is definitely the engine behind the world's search, and the problem is it is unforgiving. Not that there is an issue with it, but the thing is a single inefficient query can spike CPU to 100%, and that can definitely cause cascading failures, gateway timeouts, and massive cloud bills. The specific pain point which we as our team also experienced was that 80% of Elasticsearch performance issues stem from developers writing queries that work on small local datasets. In our case, I was working on a 5,000 docs dataset, and then I further shifted to 500,000 docs dataset, but they fail catastrophically in production, which is usually comprising of 10 million plus documents. The thing is, we in this particular case are going to deal with wildcard queries on text fields because they comprise the most common offender. As you can see, Elasticsearch is fast, but one bad query can definitely kill the cluster and can increase latency to exponential amounts. So we are going to focus on wildcard queries which are on text, and we are also going to introduce script filters which bypass the index and help not eat at the CPU, because of course we will be reducing latency through reducing CPU spikes, and also to just include examples of leading wildcards which everyone uses in every single segment or every single turn. And using these tools and algorithms and techniques, we aim at reducing the latencies from 12 plus seconds to by 85% to approximately 2 to 3 seconds or even less on a 10 million document cluster, of course. And this agent fixes them in milliseconds. So when we move forward to the solution part, our agent is a completely autonomous reasoning loop agent. It focuses on dividing the process into 5 steps. First of all, the diagnosis part, wherein they diagnose the queries using different APIs which have easily been integrated with the Elasticsearch tools, in this particular case profiling, analyzing and mapping APIs. Then we detect anti-patterns. In this case, as we have already pointed out, these are wildcards and scripts, etc. They generate the optimized semantically equivalent queries, which means it gets the job done, but it is written in such a way that it reduces the latency, because of course we don't want a lot of, in particular cases, for searching a lot of documents which have no relation with our output. The benchmark execution, which is the collector time. What do I mean by collector time? It is the Elasticsearch CPU time, which is extremely important, and that is the main focus to reduce, to improve improvement and to enhance performance, and also to help reduce latency. Last of all, they just validate results to just ensure that there is 100% data consistency, just to check whether there is no data leak or it doesn't, the optimized query is not a security loophole, right? So this is our readme file, which we will of course share the publicly available GitHub repository. It is a 7-layer diagnostic pipeline. We have divided it into different parts. It is beautifully written all over. This is our document file and the coding file, etc, etc. This is our architecture. It's a beautiful architecture. We intentionally kept it simple so as to not mess it up, and we got remarkable benchmark results. Of course, we used the dataset available on Elasticsearch through their sample data and the observability data, and we got these exact matches. It's of course divided into a lot of parts, but we could not do the results and check them on a 10 million plus documents because of course computer restraints, but we did check on 500,000 document files, datasets, and we got remarkable results which amounted to 35 to 40% improvement. These are the installation and setup parts, and now let's move on to the working part. So this is our, in this particular case, this is my VS Code environment, and I ran the backend server. This is the backend server. I ran the server already. For you, I can just run it again. So I am going to come out of the instance, and this is my app. I'm just going to press enter, and it will start running the backend server as efficiently as possible, and to connect with all the my cloud and my cluster, it will try to create that, and it will just initialize all of those things. The most important part is, in this particular case, we have added the API keys, etc., in the code itself for you to check out too, because of course this is a free trial, so it won't necessarily have an impact, but still this is how we wanted to go through. Now we are going to move forward to the front end part to just check how all of this thing is going to work. So I'm just going to come out of the instance for you to run again, just for you to see it. This is the demo dashboard. So right now I am in the Elastic Auto Fixer Agent platform in my folder, and I'm just going to run the demo dashboard which I ran. It is the web UI for you to see the results. I'm running it, and it has taken me to the website itself. This is connected to all the agents of Elastic and all the documents which I have initialized in the code itself to run and to identify the issues in those fields, etc., etc. So how this website works is right now it tells us about the details and what this website is about and what this interface is telling me. Right now this is where I have to click to identify the issues in my cluster, and that cluster can be changed, but right now I'm using the sample data of Elasticsearch. I click it, it scans the clusters for inefficiencies, and right now it has found two issues. These are the issues. As you can see, we have done all the necessary changes, and we have kept in mind that everything has to be clearly defined for the developer to understand, because most of the times when a production error is going to come up or it's going to be an accident, it's important that these issues be present all the time so as to help in debugging. So these are the critical issues. These two issues were what I had put in the data set. So the agent clearly identified it without any errors, and it reduced the latency too. We can take an action to fix it with AI. So this is the code. We can fix it with AI to find out how can it be bettered. So this is the original configuration, and this is the optimized configuration. So in this case, it's telling me that you have to use this particular query, which is a wildcard query, to get better results. Why? Because it's optimized according to the data and according to a lot of features and according to a lot of algorithms which are necessary to achieve these suggested latencies. We can then fix it, apply fix to cluster. This is the button to just fix it to the cluster on the Elasticsearch website. It's fixed. We can move forward to the second critical issue. This is done again. We can fix it to cluster, and yes, it has completed it. These two queries are done. We can see that a slight fading of these issues was noticed if you can access it, and that's the demo for you. I just also wanted to point out that we utilized Elasticsearch serverless specifically as our core engine. It's important to note that our agent leverages deep diagnostic endpoints, which includes, in our particular case, Profile API, which is for CPU level benchmarking, Analyze API, which is for tokenization simulation, Mapping API for schema inspection. As you can see, we have included all those things in the README file. Here they are, Profile, and all these APIs have been added. It's also important to note that we orchestrated the logic using the official Python client and supplemented the experience with an AI assistant created via Elastic Agent Builder. So it's important to note we included all the Elastic features and tools which have been given on their website. We understood all of them, and it was our role as hackathon participants to understand those tools and to make an agent out of it. So that's what we did. We also would like to people to contribute to these features, and it's a very important topic which can then be furthered. That's exactly what we want, and I guess that's my time. Thank you.